Hi, boys and girls. This is Mrs. D. Today in this lesson, we are going to learn how to multiply a fraction by a fraction using area model and the standard algorithm. First, let's do a little review from when we multiplied decimal by decimal. When we did this, we learned that we just need to multiply the numbers behind the decimal as if they're not there. So I know that if I did 7 times 3, I would get 21. 7 times 3 is 21. And if I write that, I would write it like this. However, that's not my answer because we don't have any decimals. We can see that there's one number behind the decimal here and one number behind the decimal here. So in our answer, we know that we should have 2 numbers behind our decimal. So our answer would be 21 hundredths. Sorry, that's a terrible decimal point. But let's model this on a grid. If I were to show 7/10, I would shade in 7 columns, 2, 3, 4, 5, 6, and 7. From here, I'm going to change my color and I'm going to shade in 3/10. 1, 2, 3. Notice how I went in the opposite direction? I did not continue on with columns because that wouldn't help me see my answer. But if I look for my overlapping blue and yellow, I can see my answer right there. If we count those, we should count 21 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So on this area model, I modeled 21 hundredths. That's something we've already learned during the year. Well, we can help take that knowledge to help us understand how to multiply fractions because a decimal is a part of a whole and a fraction is also a part of a whole. In this example, I can see that there's 2/3 right here, 3/4 right here, both modeled because this square is divided into 3 sections and 2 of them are shaded red. If you look closely over here, you can see the red, but it's hard to see that there is red actually behind there. Here, we have 3 sections out of 4 shaded blue, and again, we can see the blue here. And if I look at this model, this one is divided and this one is divided. So what we did in the answer, in order to get one answer, the 2 models are overlapped into one. So you can see that the red and the blue are there, but it makes this kind of dark purplish color. That is part of my numerator as my answer because then just as we did with the overlapping hundredths when multiplying decimals, I'm still looking for what is overlapping to be part of my answer when I multiply with fractions. So I can see that there are 1, 2, 3, 4, 5, 6 parts where the blue and red overlap, and that becomes my numerator. And then for my denominator, well, how many parts are there altogether in this whole right here? So there's 6 that are this blue color, 7, 8, 9, 10, 11, 12. There are 12 parts in the whole to give a denominator of 12. I can check this work by multiplying straight across. 2 times 3 equals 6. 3 times 4 equals 12. Let's look at another example. Here we have 2/5 times 2/3. My 2/5 are modeled with that purplish color, and the 2/3 are modeled in that orangish color. I know that all together, not only because there are 2 shaded, but there are 1, 2, 3, 4, 5 sections, and 2 are shaded. So that shows me the 2/5. And there are 3 rows and 2 are shaded in that orangish color. So I am looking for what is overlapping. This is not overlapping with anything, so that does not count in my answer. This over here is also not overlapping with anything, so that doesn't count as part of my numerator in my answer either. But this part right here has both colors overlapping. So that is going to become my numerator. If I count them, there are 1, 2, 3, 4. 4 is my numerator. And also, if I look here, 2 times 2 equals 4. And how many parts are there altogether in this model? There's 4 that I counted: 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 parts in that whole model. Also, 5 times 3 gives me 15. So another way to check my work. Let's look at this example. See if you can pause this and do this without me to figure out what the answer might be. Here, I have 3/10 that are shaded in this orange going vertically, and I have 2/5 that are shaded in this purple. I know that because there's 1, 2, 3, 4, 5 sections that way, so that is the denominator of 5, and 2 of them are shaded in. So if I look here, I can see this overlapping section where orange and purple overlap. If I count how many I have there, I see 1, 2, 3, 4, 5, 6 parts. So 6 becomes my numerator. And then how many parts are in this whole square? There are 50 parts in this whole square. I can count each one of those. I can also find the area of this whole square. We learned how to do that a long time ago, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns times 1, 2, 3, 4, 5 rows, which also shows right here, 10 times 5. We're actually finding the area of the part on the inside. Same with what we did here. We found the area. We did 3 times 2, which is why we can multiply straight across and get the answer in the same way, because we're finding the area of the square. Now let's talk about this 6 over 50. Is that answer bigger or smaller than these factors right here? We should know that because the denominator is 50, that's a really, really big number. So it means I've got to share with a lot of people. This number is much smaller in fractions than these factors. The larger the number the denominator is, the more people you have to share with, which makes your piece a whole lot smaller. So when you look at this, you can see that there is less of this reddish color than there are of the orange and the purple. There's still a lot of extra, and the overlapping part is much, much smaller. So when I multiply with fractions, I actually wind up to get answers that are smaller. That's really weird because when we multiply, we are used to getting much larger answers. But this time we're multiplying with fractions that are not whole numbers. So when I multiply together things that are not wholes, I wind up getting answers that are smaller each time instead of larger. Because I had to divide this whole square here into much smaller parts. So when I divide it into columns, and then I divide it into rows, and then I look at the overlapping part, each part keeps consistently getting smaller and smaller. Let's look at this example. If I have 1/2 times 1/4, I could also say this 1/2 of 1/4. That word of means to multiply, and that becomes important especially for your middle school math. Of means to multiply, so 1/2 of 1/4. If I were to draw this, here's my model, and I want to show half. So split it right down the middle, and we're going to color in 1 out of 2 sections because that's what half tells me to do. Now I'm going to change my color, and I'm going to model 1/4. So I'm going to cut this into 4 rows. Oh, that's not quite even, but for the most part, you're going to see my overlapping here. Then I'm going to color 1 out of those 4 sections green. And if I look for the part that shows me the overlapping black and green, I should be able to find out what my answer is here. So if I were to write this, and I'll change my color and I'll write it in red, 1/2 times or of 1/4 is going to give me what? Well, how many pieces have both green and black? Just one. The one right here. And how many pieces are in that whole square that I drew? There's 8 now. I know that my answer is reasonable because when I multiply 1 times 1, I get 1. And when I multiply 4 times 2, I get 8. And that's just like finding the area. This overlapping is 1 square, 1 column by 1. If I find the area of the entire thing, there are 2 columns and 4 rows, and 4 times 2 equals 8. Let's do one more example, but in a word problem this time, so you can understand when I would have to multiply in a word problem. James noticed that there was 1/3 of 1/2 gallon of strawberry ice cream left at the end of his birthday party. How much strawberry ice cream was left? Here I see that word of. That's telling me that I need to take these two fractions and I need to multiply them. So let's set up my equation. 1/3 times 1/2. And I encourage you to pause this video here, see if you can draw this area model on a piece of paper, and also use the standard algorithm of multiplying straight across to see if you can get your answer in 2 different ways here. Hopefully when you unpause, you and I will match for our answers. When I start my model, I can draw my square or my rectangle, doesn't matter which one you draw. And I need to model 1/2 and 1/3 all in the same square. So I'll do my thirds in red, and I'm going to use yellow this time. I'm going to show my half in yellow. So now, I forgot to do one important step. I forgot to shade my 1/3. I drew my thirds, but I didn't shade one of them. So I'm going to go back through and shade my 1/3. There's that. Change my color because now I also need to shade my 1/2. All right, I shaded 1 out of 2 pieces. I also shaded 1 out of 3 pieces. So now I'm looking for the overlapping part of both my red and yellow for my answer. How many pieces have both red and yellow in them? Just one. This one right here has both colors in it. This one doesn't count, and these ones don't count in part of my answer because they don't have both colors in them. The extra here and the extra here are part of my problem, not part of my answer. So again, once I did my multiplication, 1 times 1 equals 1, and I can see where 1 is coming from right here. Now I need to find how many parts are in my whole square that I drew here, and there are 6 parts altogether. I also know that because 3 times 2 is 6, and the area of this whole square, 3 times 2, gives me 6. Now think about this. Let's go back to why is this answer much less than my factors or the numbers I'm multiplying with? Again, remember it is much smaller because I took 1 square and I divided it into thirds, and then I divided it again into half. I have to divide a whole in my area model in order to see where my answer is going to be. And because I'm actually dividing, because I have fractions, I'm going to get a much smaller answer. So I'm using multiplication and division to show this area model because you're multiplying to find the area, but you're dividing to see the parts. Now you've learned how to multiply fractions with both the standard algorithm and the area model.